Hello mathematicians, welcome back to another video. I haven't done a spin in a while here on this or the main channel. So, linear functions yet again. If you want to know more about linear functions, all the basics, etc., everything you need during your school life, or maybe you just need a refresher of the topic, you can find the link to the complete playlist down there at the top of the description, as well as the info box up here. And now we are going to dive right in. In last time we have applied the time a little bit, meaning we have reconstructed functions equations, linear functions. For example, we found out what the y-intercept and slope, for example, is. And today I would like to go through something that is going to continue being there up until higher grades, even if you study mathematics. It's the so-called point test. I don't know if it's a strict English-speaking term that you call it point test, but what we want to do, we want to find out if certain points lie on the graph of our function. For example, we have this function right here, and an exercise could say, well, you have 2 points given. Do either of these, or both, or maybe none of those two, lie on the graph of this function? And we're going to go through the main procedure, and it doesn't matter if you have a first-degree polynomial, a second-degree, a fourth-degree. It's always the same procedure that we are going to go through, and I hope you are going to enjoy this video. Now here's what you are going to do. Well, we have a point given, and what can we do with points? Well, we can plug points into functions, and this is what we are going to do. It doesn't get any harder than this, okay? You just need to plug all the x's into here, and then see if the y value that you have here is the same as the one that you get out on the other side after plugging your x value in. Let us do this for the first one. So what about f evaluated at 0? Well, all you have to do is plug 0 into each and every x here, and that's really easy with a first degree polynomial. So 0 into here, 3 times 0, if you have no apples, then you have no free apples, meaning that 0 minus 1/2 is negative 1/2. And that's good. I mean, this right here is a y value. If you evaluate a function at a certain x value, you're going to get a y value out on the other side. And this is exactly the one that we are having here in this point. And thus we are done. The point is exactly on this graph. Okay, next up, point number 2. What about it? Well, we are going to plug the 3 into our equation and see what we are going to get. Let's evaluate f at x being equal to 3. Well, what are we going to do? We are going to plug the 3 into each and every x here, meaning we are going to get 3 times 3. And then a minus 1/2. Okay, so what's 3 times 3 exactly? This is hence nothing but 9 minus 1/2. And now you could do fractions, okay, fraction addition, or you can just say 9 minus 1/2. Okay, take 1/2 away from 9 is 8.5. But no matter what you do, if you have a decimal expansion or a fraction, 8.5 is not equal to 6, meaning this point doesn't lie on the graph of this function. And hence we are done. We have checked both points, and only this one is exactly part of this function right here. Okay, let us go through a second example. There are actually other ways to see if a point really lies on the graph. For example, here you might notice that our x value has been 0. And when is this the case? Exactly when our graph cuts through the y-axis. And this is exactly our y-intercept that we're having here. Meaning what you can do is, since you know that the y-intercept is exactly the y value corresponding to the point x being equal to 0, you can just cover up this part and see if this right here is the same as the y value, and then you are done. You can go through kind of the same reasoning here on this one. So let us plug the 0 into here and see what we are going to get. So if we have g of 0, that's a new function, g, we are going to get, okay, 0 into here, negative 1/2 times 0 is 0, obviously, plus 4 is going to give us 4. Meaning, we get 4 instead of 0, meaning this right here doesn't lie on the graph. But why is this the case exactly? Well, it does make perfect sense. We have talked about this before. Only proportional functions go right through the coordinate system's origin. Those are the only class of linear functions which go through the origin. But this right here is just a regular all linear function which is going to be shifted upwards by 4 units in the positive y direction. Meaning, since this right here is a y-intercept, okay, like I said before, you can cover this up and see what the y-intercept is. We are not going to get 0, 0 ever as a point. And this is quite a nice reasoning that you can go through. Now what about point number 2? I mean, let us just plug everything into here yet again. G evaluated at 2 is going to give us, okay, negative 1/2 times 2, negative 1/2, I'm going to put this into parentheses, times 2, and then plus 4. Now let's go through some calculations. I mean, negative times positive is going to give us negative overall, so this is negative something. 2 times 1/2 is 1 whole cake, you could say, so this is 1 plus 4. And what's 1 taken away from 4, well obviously that's 3. And this right here holds. 2, 3 is a point that lies on the graph of this linear function. And hence we are done. I mean, this is just really easy. You just need to be able to calculate a bunch of numbers. This is all you really need to do. But it's something extremely important that you are going to see for the next few years if you just started out with linear functions. So never forget about it and try it out. Try out some functions that you come up with yourself and some points and just see if they lie on the graph of your choice. Other than that, thank you guys for watching. If you enjoyed this video, please like, subscribe, recommend, channel like. Don't forget to check out our newly launched platform STEM Merch. It's a STEM shop and we are offering a bunch of cool stuff like this Mandelbrot set, a canvas print, or for example our clock or merchandise. So if you enjoy stuff like this, make sure to check it out. Link will be down there in the description. And up until next video, I wish you guys a flammable day. Ciao!